Welcome and thank you for standing by. Participants are in the listen-only mode until the question-and-answer session of today's conference. This call is being recorded. If you disagree, you may disconnect at this time. I would now like to turn the call over to Ms. Sarah Fraser. Thank you, and you may begin.
Thanks. Hi, everyone. Welcome, and thanks for joining today's media teleconference. I'm Sarah Fraser from NASA's Office of Communications. On October 14th, an annular Ring of Fire solar eclipse will be visible in the U.S. on a path stretching from Oregon to Texas. Even outside this path, people across the contiguous U.S. will have a chance to see a partial solar eclipse. Today, we've gathered NASA experts to talk more about this eclipse, how it relates to NASA science, and how people can safely watch and engage with the eclipse. Our speakers today are Peg Luce, Acting Heliophysics Division Director at NASA Headquarters, Alex Lockwood, Strategic Content and Integration Lead for NASA's Science Mission Directorate at NASA Headquarters, Kelly Korick, Eclipse Program Manager at NASA Headquarters, Lika Guhafakorta, Heliophysics Program Scientist at NASA Headquarters, and Elizabeth McDonald, Heliophysics Citizen Scientist Lead at Goddard Space Flight Center. We will start with brief opening remarks from these experts and then open it up for Q&A. For those of you on the phone line, you can join the queue to ask a question by pressing *1 on your phone. And with that, I will turn it over to Peg to start us off.
Thank you, Sarah, and hello, everyone. The annular eclipse on October 14th is going to be a spectacular event. We not only get to witness the awe and the wonder of seeing a beautiful Ring of Fire eclipse, but it's also a very special time for NASA as we are kicking off what we are calling the Heliophysics Big Year. Heliophysics is the study of the sun and its influence on, well, everything. From Earth to all the planets in our solar system and on out into the interstellar space, the sun touches everything. The Heliophysics Big Year is a public engagement campaign designed to share the science of heliophysics broadly, make this information accessible to all, and showcase NASA's heliophysics-related efforts. We're challenging everyone to participate in as many sun science activities as possible leading up to and around the solar maximum, which will happen toward the end of the Heliophysics Big Year, so we'll be building up to it throughout the year. The Helio Big Year will begin with this annular eclipse in a couple of weeks and continue until December 24th, 2024, when Parker Solar Probe, the mission that touched the sun, will make its closest approach to the sun. We want everyone to join us in this global celebration of our sun. And with that, I'd like to turn this over to Alex Lockwood.
Thanks, Peg. And I want to focus on the beginning of that Heliophysics Big Year, the annular solar eclipse that is happening on October 14th, just a few short weeks away. The path of this annular eclipse crosses a big swath of the U.S. from Oregon all the way down to Texas and touches parts of California, Nevada, Utah, Arizona, Colorado, and New Mexico. This is a huge portion of the U.S., and actually there are over 6.5 million people who just already live in this path of annularity. So 6.5 million people on October 14th can walk outside and safely, hopefully, view the sun. There's another 68 million people who live within 200 miles of the path of annularity. So a few hours short drive, and you can have over 70 million people witness this incredible celestial alignment. And everyone actually in the entire contiguous United States can witness a partial solar eclipse, if not the annular solar eclipse itself, on this date for a few minutes. Now, to witness this amazing event safely, if you are on the path of annularity, or if you're not on the path of annularity and you can see a partial eclipse in the U.S., you need safe glasses. Now, these are not sunglasses, and they're not even welder's shields or glasses. You need certified ISO 12312-2 compliant solar eclipse glasses. There are plenty of safe sellers of these glasses online, and we encourage folks to find a safe pair NASA is also providing many of them to our partners and locations that we will be sharing. And we cannot stress enough how important it is to obtain a pair of safe, brand certified solar eclipse glasses in order to witness this annular event on October 14th. And now to hear more about what NASA is doing, I will pass it off to Dr. Kelly Corrick.
Hi, thanks, Alex. We are doing so much to prepare for this annular eclipse on October 14th, 2023. And what a big part of that is our NASA live broadcast. We'll be broadcasting from 11:30 a.m. Eastern to 1:15 Eastern. We're going to be broadcasting from Albuquerque, New Mexico, as well as Kerrville, Texas, and White Sands, New Mexico, where we'll be launching 3 sounding rockets into the atmosphere to do some science. So there'll be several hours of programming showing you the annular eclipse, as well as highlighting NASA science, both in heliophysics, as well as citizen science projects, and many others. So there's the event in Albuquerque, New Mexico. We're going to be at the Balloon Museum, as well as the Balloon Fiesta. In those areas, you can interact with NASA experts and subject matter experts that can tell you all about the sun or other fun NASA activities, ranging from Webb and Hubble to the Globe Observatory, looking much closer here on Earth. At Kerrville, Texas, at Louise Hayes Park and River Festival, we'll have, again, NASA experts available to answer your questions and to talk with you about the solar eclipse and other NASA science. So if you look for events and resources, other events and resources on our website, go nasa.gov/eclipses. And this is really a unique event, and why we're so excited about it is that the next total eclipse happens in April 2024, but then not again until 2044. And the next annular eclipse seen in this part of the country is actually going to be in 2046. So it's going to be a long stretch that we will not see this celestial phenomenon again. So we're really encouraging folks to go out there and safely observe this, again, making sure that you have those sort of ISO-certified glasses in order to view this event, or a indirect viewing method such as a kitchen colander or something like a pinhole camera. Again, things you can look up on the website. So now with that, I'm going to pass off to Elizabeth McDonald to talk about citizen science.
Thanks, Kelly. I'm really excited to talk about these NASA-funded projects that anyone can contribute to and join in on the science discovery that is possible during eclipses, both annular and total. Just last week, we had a webinar featuring many of these projects, 5 of these projects that are preparing for the eclipses. That was hosted by our SciStarter platform, the SciStarter Citizen Science platform. 100 years ago, volunteers guarded the telescopes that were used to make these rare observations super close to the sun during eclipses. But now the volunteer teams can actually field telescopes. And we are funding a variety of projects that involve different mechanisms, different instruments that people can use to contribute to different aspects of the science, ranging from the Sun Sketcher project, which just involves cell phone apps and is looking for the observations of what's known as Bailey speeds during the total solar eclipse. They will be testing out their apps during the annular eclipse. And then there are projects, if you just have a camera, you can participate in the Eclipse Mega Movie project. They're also interested in all photos of the eclipse that people will take. There's also projects that are creating, using telescopes to observe the eclipses both on the path of totality and off the path of totality, the Dynamic Eclipse Broadcast Initiative, otherwise known as DEB, and the Citizen Kate project, which both of these projects, in terms of gearing up for the total solar eclipse, teams can join now and start to get familiar with what they would need to do. There's also ways that people can participate involving radio waves. So the annular eclipse in October is going to be just as spectacular in terms of its effects on the upper atmosphere as the total solar eclipse. So there's a project called HAM-SCI, which actively engages ham radio operators throughout the world. They're having contests for basically making connections and probing the atmosphere that has scientific utility, helps us understand the details of how the atmosphere changes during this really fast sunset of an eclipse. So you can check out their QSO signal contest. And then also, if you're not a ham radio operator, there's a project called Radio Jove that involves a build-your-own radio telescope that observes the eclipse in different frequencies and also observes dynamic things that might be happening on the sun and even Jupiter as well. So that's one that you can, both of those are projects you can continue throughout the Helio Big Year. There are a couple projects outside of heliophysics. If you have students, the Globe Observer Project is engaging people in earth science and changes you can feel during these eclipses, so that's another one. And there's even projects, citizen science projects involving exoplanets and how eclipse phenomena are part of how we're discovering exoplanets. So that's another one to check out. And you'll want to do them all, but really, hopefully people can find projects that they might want to contribute to. And there's other citizen science projects they can take part in during the rest of the big year, during this time of the sun's most active period. So we're really excited about how that can get started and continue on. And I'll quit there for now. Thank you. And pass it on to Lika.
Thank you, Liz. Well, by now, all of you have heard the variety of ways that NASA is actually trying to bring the eclipse to you, of course, along with Mother Nature. But NASA is best at when it's exploring uncharted areas of science. And eclipses offer those rare opportunities to study the sun and earth in novel ways. Now, 100 years ago, as Liz mentioned, there was something else going on. 100 years ago, scientific attention was focused on the study of the sun, its outer atmosphere, the corona, and other astrophysical phenomena. That began to change when we started looking at the sun and earth as one system, or rather, I should say, sun, earth, and moon as one system, and look for causes and consequences for eclipses on Earth's atmosphere. Now, observing conditions during total solar eclipses offer opportunities for exploring the physics of the solar corona. And this is kind of interesting. We have lots of satellites, but currently these observations we take are unattainable from any other observatory, whether ground or space-based. And we do this with different approaches and tools, all founded on the same principles of colors of light, spectroscopy, different wavelength. During a total solar eclipse like the one that's going to happen in April, we will take advantage of this rare view of the sun's outer atmosphere, the corona, with researching with high-altitude research aircraft that will be capturing images of the eclipse from 50,000 feet above Earth's surface, as well as all sorts of other observations from the ground. During the annular eclipse, you will see the chromosphere. The pink blobs are H-alpha. This is where hydrogen atoms at the surface of the sun behave like gas, and the color is because of the intrinsic properties of hydrogen. That's what makes it so beautiful. Now let's go to our atmosphere where we live. The ionosphere, an electrically charged outer shell of Earth's atmosphere, is affected, not just affected, but created by incoming sunlight and particles like X-rays, solar extreme ultraviolet, and particles, as well as processes which are in the deeper levels of the Earth's atmosphere. Although the ionospheric effects of solar eclipses have been now studied for over 50 years, many unanswered questions remain, and some include, how much of the ionosphere is affected by the solar eclipse, and for how long? Why is this the case? During a solar eclipse, there's a significant drop in the electron density in the ionosphere, these charged particles which are charged by the sun. These changes in the ionospheric effect, radio waves, as Liz was mentioning, and the GNSS signals that travel through this layer of the atmosphere. The frequencies that are most affected are those used by ham radio operators, AM band radio stations, and military over-the-horizon radars. During the annular solar eclipse, as Kelly mentioned, there'll be 3 NASA-funded suborbital rockets. They're sounding rockets. This is the first time we have done this because such an opportunity, comes one in 400 years probably. And they will launch during and after the peak of the eclipse and before the eclipse from White Sands, New Mexico, to gather data on this electric and magnetic fields, electron density, and temperature. And the set of experiment together is called atmospheric perturbations around the eclipse path, or APEP. Also, observations from radio operators will be gathered to see how the charged upper atmosphere, the ionosphere, is affected during the eclipse. Finally, solar eclipses can impact Earth's weather and its atmospheric composition. Surface temperatures can change briefly. There is anecdotal evidence of wind speed variation. Model simulations that we have done also show the impact of radiative cooling on the stratosphere, and the changes to atmospheric composition is also observed. So the amount of observation that not just NASA, but we collectively will gather during the eclipse, the annular eclipse, and the total solar eclipse with all our satellites, it's going to be absolutely breathtaking for science. Thank you.
Thank you very much. All right, with those comments, we are ready to open it up to questions. So as a reminder, if you're on the phone line, you can press *1 to get into the question queue. And when you do ask a question, please state your name, your affiliation, and if your question is directed at anyone specific. And for our speakers, I will ask you to identify yourself when answering a question if it wasn't directed at you specifically, just so that our listeners can distinguish people's voices. All right. It looks like we have a couple questions in the queue, so I will let our operator open those lines.
Thank you. And just as a reminder, if you wish to ask a question, please press *1, unmute your phone, and record your name so you can be brought up for your question. Our first question comes from Josh Diner. You may go ahead.
Hi, Josh Diner with Space.com. I believe this question is for Dr. Couric. What would a government shutdown, what kind of effect would a government shutdown have on the programs and science activities that NASA is hoping to conduct during the eclipse in October?
Hi, Josh. This is Sarah. I can actually answer this one. So while it's not appropriate for us to speculate on the government's operating status, we are monitoring closely, and we expect to have additional information later this week.
Thank you.
The next question comes from Adam Kovac. You may go ahead.
Hi, this is Adam Kovac from The Messenger. I'm curious about these 3 rockets that are going to be launched on October 15th. If you can give a few more details about what exactly they'll be measuring and just any more details about the mission profile, that would be great.
Lika or Kelly, do you want to talk about that?
I'll start, Kelly. You can add to it. These are typical sounding rockets. we launch many sounding rockets from White Sands, New Mexico. You know, the orbital duration is generally sort of 5 minutes. They are going to carry instruments specifically to measure the impact of before, during, and after the eclipse. And the reason for that, and they are actually measuring in situ, right? So they are going to measure the fields, electric and magnetic, and they are going to measure the particle distribution. And the reason that there are 3 rockets is, and then they're measuring at different times, is because the moon is moving rather fast. And so the insolation, the amount of radiation we are cutting off, you know, what impact we can quantify based on geometry how much of that radiation is reaching that particular point. They're trying to really quantify the relationship between that radiation that's coming in and how is the ionosphere, the atmosphere beneath, responding to that. And this allows us to really understand the impact of solar radiation. But remember, ionosphere kind of is dominated by 2 forces. Of course, a big force is what charges it, which is solar radiation. But there are all kinds of effects that come from below, you know, like gravity wave propagation. And all of that is also going on because in that local environment where temperature can drop significantly, you're beginning to see, dynamic changes with pressure, with temperature. So this becomes basically a laboratory where you take your models and you take this observation and you begin to interrogate those 2 to get to the bottom line.
That's great, Lika, and this is Kelly Corrick, and I'm just also going to add that one of the great things that's also happening is there are balloons supporting the measurements here, because as you said, there's going to be different levels and how kind of the energy and the particles and things change, not only in the ionosphere but above and below. So there will be some measurements done by balloons in addition to this, and the rockets are going to be launched about 35 minutes before peak eclipse, during the peak eclipse, and then 35 minutes after to, again, follow that dynamics and really help with our models to better understand our ionosphere and our atmosphere in general.
Our next question comes from Jim Siegel. You may go ahead.
Oh, thank you for taking my call. I'm with NASATech.net. You mentioned the effect on radio waves as a possible effect of the eclipse. I'm wondering if there's any other disruptions that are likely or anticipated in any other aspect of life in the United States or somewhere else in the world, or maybe even the International Space Station. Thank you.
Liz, do you have anything you want to add on the radio waves front, and then I will open it up to anyone else who wants to add to that.
Yeah, I don't. So Lika talked about how the ionosphere changes, the density changes during an eclipse. I think there are also waves that can happen, and really it's a chance for effects all the way from the ground to the very edge of space and to be observed. And so in that way, it's really a chance to integrate our observations in ways that aren't usual. So I don't have any more specifics. The ham-sci group certainly has more specifics on different frequencies. Some frequencies people have more connections, some they have less connections. And then the other thing in terms of disruptions that your question made me think of is the Eclipse Soundscapes project, which is actually recording other effects of the eclipse in terms of on the biological landscape. So, you know, there's nighthawks that can come out, and all kinds of different effects that animals and people respond to eclipses. So that was the other thing that came to mind at first. Thank you.
I can take a shot at it also. So I'll tell you something cool about these radio waves. So I already mentioned, right, sort of the ionosphere breathes with solar radiation. And if solar radiation is cut off, it just kind of, a lot of the ions neutralizes. And a cool effect of that is, especially if you're a ham radio operator, the radio wave propagates much longer than usual. So you can hear, if you're a ham radio operator, like weird stations and stuff like that. I haven't experienced it, but I can totally imagine, and it would be so much fun. With regard to really impact in the rest of the world or International Space Station, so what we have to remember that the path of the eclipse is extremely narrow. That is path where, for the annular eclipse now, I will refer to, where sort of 90% of the solar disk is blocked, sort of varies between 100 to 150 miles in terms of width. Of course, it goes from, Oregon to Texas. So it's a very, very small path. And then, of course, the larger penumbral shadow is everywhere where we get a lot of light. And in fact, in general, during an eclipse, we get about 92% of the solar radiation. So we are not expecting anything catastrophic unless, and there is no catastrophe even if you're in the path of totality, but there will be changes in temperature and, wind profile and things like that. And the other question you asked is about International Space Station. So International Space Station goes around the Earth every 90 minutes. I haven't looked at it carefully, but I'm expecting that it is definitely going to encounter moon's shadow. And it will be a spectacle for them to behold when they can see the eclipse. In general, for International Space Station, I want to bring up something else that is not eclipse related. And that is that we are in the rising phase of solar cycle. And we've been getting lots and lots of, solar flares, coronal mass ejections, and any of those things can happen anytime. But we have satellites, we have our physics model with which we try to provide the understanding with which NOAA does the prediction, and so they can take mitigating steps. Nothing catastrophe. I hope this eclipse is just beautiful.
Hi, this is Peg Luce. Also, the way I think about this is that it provides such a wonderful opportunity for almost a scientific experiment. So we know that the effect is going to be that we block off most of the solar radiance for a brief period of time, and we look for impacts like changes in temperature, changes in the ionosphere, changes in radio wave propagation, and so on. And if we can measure those things in this lab experiment that the moon and the sun are providing for us and measure very carefully, then we can extrapolate from those observations to what the effects generally are and in the larger context. So again, it's like Lika said, it's not large enough, not a big enough effect to be catastrophic, but it is certainly an opportunity for us to learn and apply what we observe in this unique situation to our models and our understanding of the system.
Thank you.
The next question comes from Marcia Dunn. You may go ahead.
Yes, hi, Marcia Dunn at the AP. I'm wondering, do you sort of see this as a dry run for the April total eclipse? Will there be even more science opportunities and observations in April? How many balloons are going up? Are those going up from White Sands or all over the place? And is that what the timeline was for the balloons when you were talking about them being set off 35 minutes before, during, and after? Because I didn't know if you were talking about balloons or rockets. And if it wasn't the rockets, when are the rockets being launched? Will they go up simultaneously, or will they also be staggered? Thank you.
Thanks. I will let Kelly answer the first part, and then maybe Kelly or Lika for the questions about the April science and the balloon and rocket details.
Great. Thank you so much. Yes. So for 2024, we are definitely looking forward to that total eclipse and using all of the things that we've learned in 2023 to make 2024 an even more impactful scientifically and public outreach and all of the things that NASA are doing, and as well as doing this safely, making sure that everyone's excited about this and able to safely observe the eclipse in 2024. In terms of the rockets, so the rockets are what is launching 35 minutes before peak, launching at peak, and then 35 minutes after. So there will be balloons from White Sands that will, again, fly underneath basically the rockets in order to take data. NASA does also work with the ballooning project that will have balloons released across the path that are a bunch of college teams that actually are able to take data with those balloons, again, in the atmosphere and the changes that happen around the eclipse. So there'll be balloons launched from New Mexico. There'll also be balloons launched, again, across the path during both the 23 and the 24 solar eclipses.
I can add a little bit more to the 2024 observations. I think this is actually our third run from NASA. We had a spectacular total solar eclipse in 2017 that we learned a lot from. We have this annular eclipse right now, and then comes the total solar eclipse. So along with the celestial feet, what we have not told you are over the 100+ operating missions that NASA has at all different vantage points, something that is going towards the sun, and some spacecraft that are actually in the interstellar medium, and every manner of spacecraft at other planets and in our environment at Earth. They are all going to contribute data in some way, some more, some less. And what we do is we really collect those information, and they are really valuable when we are trying to find ground truth answers from our models, because every model is to begin with theorize, and we need observations to validate them. And eclipses like this provide sort of control experiment, as Peg was mentioning. Along with that, we are utilizing our airborne spacecraft. We've added to that fleet flying a kite, which we never imagined, but we did a test run this April from Australia. We have all sorts of array of ground-based, superdone experiments, data that are being collected by partner agencies like National Science Foundation to really sort of drive in to the understanding of what drives the ionosphere and how. So there's just like a plethora of stuff that will be collected in terms of observations and then analyzed in terms of science. Yes, we are preparing.
If I could follow up, how many balloons do you anticipate being released everywhere in terms of your science project, and how high will the sounding rockets reach?
That's a good question. We are anticipating each of the states to have a balloon launch from the college students, and then one balloon for each of the rocket launches. So around White Sands there will be a few more, and then one in the states around the totality for the college students.
And then Lika or Kelly, are you able to answer about the sounding arc at altitude?
I'm trying to calculate it in my head. My head doesn't work very well anymore. But, you know, it's about a 5-minute kind of orbit, right? It goes up and comes down by gravity. So we should be able to compute, but I don't have a number in my head. Peg, do you know? I mean, yeah.
Checking.
I just pulled it up here. It's between 45 and 200 miles is where they'll take measurements.
Oh, thank you.
All right, did that answer your questions, Marcia?
Yes, it did. Thank you very much.
Okay, great. We have a couple questions that we've gotten from social media, so I will go to those. But in the meantime, for our phone participants, if you have any other questions, please do get in the queue by pressing *1. But in the meantime, this is a question that came in on X. And the question is Solar Cycle 25 going to require better eye protection than standard Eclipse viewers? And I don't know if Kelly or Alex wants to take that.
I can take a shot at it. This is Kelly. And the solar activity does increase in terms of the fact that we're at a maximum, but it doesn't really increase the visible light that we're going to get into our eyes. So it is important at any solar eclipse to use those solar viewing glasses or an indirect viewing method. And what might be exciting, what might change because of the time in the solar cycle that we are seeing these eclipses is when you have your glasses on, you might see more activity on the sun, either sunspots or perhaps prominences or things hanging off the sun, these little protrusions that come off of the sun. And then once you reach totality in 24, that difference will be when you see the corona, it'll be a lot more active and again, many more of those prominences and other things that you will see. You will still need the same eye protection so that you would need at any other time.
All right, thank you. Okay, I don't currently see any other questions in the queue from our call-in participants, so unless there are any more, I'm just going to talk for a few seconds in case anyone wants to get in the queue. So just a reminder that on Eclipse Day, we will have a NASA live broadcast that you'll be able to watch on the NASA website or NASA social media. So we hope that you'll join us online if you are not able to watch in person. And again, just to reiterate that if you are watching in person, you need to do so safely with that eye protection, which are Eclipse glasses, a certified solar filter, or an indirect viewing method. And let's see, I'm not seeing any other questions in the queue, so I think we're probably going to wrap up here. Yes, so the last few things I want to say are if you want to listen back to this call, you can listen to the recording on the YouTube link that is currently playing if you're listening that way, or you can dial in for a replay at 800-945-3639, and that will be available for 30 days. Otherwise, if you're looking for more information about the eclipse, the NASA Live broadcast, citizen science activities, other ways you can participate, or of course, that all-important safety information, you can visit go.nasa.gov/eclipses. And I think we will wrap it up there. Thank you so much for everyone who joined.
That concludes today's conference. Thank you for participating. You may now disconnect.